finding the nth term of a sequence. Sometimes the sequences are linear, sometimes they're quadratic. So here's an example. Excuse me, if you have this sequence, so these are all of our terms. So I always add stuff like this to it. So this is n is when n is 1, the sequence, which could be called f of n, is 4, n is 2, the output is 10, and so on. So when n is 5, the output is 28. So I do this, that way I have something to refer to that's a little more concrete, that it just helps me keep everything nice and clean on the paper. Very first thing you want to do is you want to check to see if it's linear or quadratic, and the way you do that is you just take the difference of consecutive terms. So here the difference is 6 for the first ones, and then the second is 6 and 6 and 6. So this is linear because the first change is constant. So what this means is that it's going to be 6 times n is going to be part of our answer right here. Okay. Now we have to figure out how, when n is 1 and we put in 1 for this function right here, 6 times 1 plus or minus something, we have to get a 4. Also, when n is, I don't know, say 3, so 6 times 3 plus or minus something equals 16. So we have to figure this out. It's pretty easy to see, though, that this is just going to be a minus 2 here, and let's see, that would be 18. And we need to be, so you would subtract 2. So our answer is going to be f of n is 6n minus 2. This is an important skill, the linear, being able to find the linear equation for a sequence, because sometimes you have to do this even when you have a quadratic. So let's keep this in mind now. One thing you want to do is you want to just check. So I'm going to check, I'm going to use not 1 or 3 or to use those, I'm going to use 5. So I'm going to do 6 times 5 minus 2. That's my answer. I better get 28. 30 minus 2 is 28, so I'm good. Alright, now let's look at a simple quadratic. Papers are stuck together. So let's look at this simple quadratic right here. Let's look at negative 1, 5, 15, 29, and 47. Okay. So I always go in and I add this stuff. Okay. Looking at the differences, the first difference from negative 1 to positive 5 is a difference of 6. And then it's a difference of 10. And then it's a difference of 14. This might get mixed up in your head. It's 18, but see, check this out. The second difference is 4. So this difference here would be 22. It's going to go up by 4. So the next difference right here would be 22. So this one, I'm guessing, would be 69, because 47 plus 22 is 69. So that's not given to me in the problem, but I'm guessing that that's going to be how it works. All right. So you see this difference right here of 4. Take that difference, it's quadratic, divide it by 2. You get 2. So part of our answer is going to involve a 2n squared. Okay. Let's just make sure to see if this is our answer. If I plug in a 2 right here, 2n squared, that would be 8, not 5. Maybe I can just subtract 3, because look, that would be 8. I need to be 5 to subtract 3, then that would work. So here's what I'm saying. Maybe it's 2n squared minus 3. I'm going to plug in a 4. 2 times 4 squared minus 3. Let's see here. 16 times 2 minus 3. That's 32 minus 3. Hey, that is 29. That works. Now let's say you couldn't figure it out quite that easy. Let me show you another way you can do this. So you've got all this information, and let's say you didn't realize this was true. So this doesn't exist anymore. So here's what you can do. Let's make a new table. Okay, so that's n. We have 2n squared. So, and we also have our original function. So what I'm going to do is I'm going to make list right here of what we've been given. So these, I know that these are the numbers we've been given, so I just took those from up here, and this is what my answer is so far, and the way I got 2n squared is from dividing this second change by 2. So 2, 8, let's see, 3 squared is 9 times 2 is 18, 4 squared is 16 times 2 is 32, and this will be 50. Look at the difference now. This is what you do. You figure out, see, this is what we have so far, and this is what we need. Okay? So look, when I put in a 1, here I get a 2, but I need it to be negative 1. That's a difference of 3. And this is also a difference of 3, and this is a difference of 3. They're 3 too high, so 2n squared minus 3 is my answer. Okay? So with that, good luck. I'm going to do another short video of a little bit of a problem that's a little bit more complicated. So, well, good luck.